All right, the last tool that we're going to be using to model the behavior of a system is called a behavioral state machine. And it's called a state machine because it takes a single object, an instance of a class, a single object, and it traces an object over its own lifetime. And many of the objects are going to change their state from the beginning of their life to the end of their life. And if you remember from your studies in object-oriented programming, the state of an object is the value of its attributes at any given moment in time. And over the lifetime of an object, it can change states frequently. And so a behavioral state machine, also known as a state machine, is a way that we can track the different states of an object over time. And we can also identify what are the triggers or what are the events that occur that would force an object to change from one state to another. And so if you look in figure 616 in your textbook on page 254, you are going to see the elements of a behavioral state machine. This is going to be in the section called Behavioral State Machines in chapter 6 of your textbook. A behavioral state diagram is made up of several different features, elements. The first element would be the state. There are going to be a number of states that an object passes through during its lifetime. There are indicators. There's an initial state and a final state that are indicated by circles and hollow circles. There is going to be a transition, which is a line connecting states to indicate the flow of the state from one to another. And then there is going to be an event. An event is going to be a text field above the transition line indicating the trigger or the event that occurred that caused the object to move from one state to the next. We're going to create a behavioral state machine in Microsoft Visio. And so if we go into Visio, we are going to start a new diagram under software, and in Visio they are called state machines. So I'm going to select a state machine, and it is going to give me some of the shapes that I need to create a behavioral state machine. So the first thing in creating a behavioral state machine is to decide which to decide which object I want to diagram. And it's important to select an object that is going to change its state over its lifetime. Because if an object is never going to change the values of its instance variables, then it is not necessary to model its change in states. For example, if I had a patient object, an instance of a patient class called Mr. Jones, at the beginning of Mr. Jones' lifetime, he is going to be a new patient. And then at some point in time, Mr. Jones is no longer going to be a new patient. He is going to be a current patient. And then perhaps after Mr. Jones moves out of state, he is going to be a former patient. We're probably never going to delete him out of the system because that would ruin our history, transaction histories. But we're going to end date him, or we are going to archive his file, and so he would become a former patient. And so this patient object over its lifetime is going to change states. So the first thing that we need to do is we need to decide on an object within our system that we want to diagram to change states over time. So let's say, for instance, that we are modeling a patient who is going to be having some problems, goes to the hospital to be checked in to try to find out what's wrong, and at some point is released from the hospital. I am going to create a behavioral state machine for a patient object over time. So we're going to start our behavioral state machine diagram with an initial state, and we're always going to end with a final state. There are going to be a series of states in between, and so I'm going to drag and drop some states on my diagram. So the first state, if I double click on it, I'm going to be able to indicate that this is our patient when he is entering the hospital. And I'll zoom in so we can see this. The first state of a patient after he has been created is where he is entering the hospital. Another state that our patient is going to move through might be called admitted. They will be admitted into the hospital. Another one of the states of our patient probably going to be released from the hospital. And then sometime during being admitted and released, there is a very good chance that our patient may go through something called under observation. And once the patient is released from the hospital, there will be a final state, which I'm going to use to indicate, I'm going to use this hollow circle to indicate that the patient is no longer under our care. They are no longer considered a patient within this system. So, now let's indicate the transitions between the two. If I just go to the connector tool and select under my home tab, select the connector tool, then I can just select one from the next, and it will give me transitions from one state to the next. The first transition would be a patient when he is very first created upon entering the hospital. And so the trigger that is occurring, the event that is occurring, I'm going to double click on the transition line, and I'm going to type in the name of the event. Enters hospital. And I'll zoom in on this so that we can see it. That is the event that occurs that causes the patient to change from an initial state into a state that can be termed as entering the hospital. And then the event that is going to occur between changing a patient from entering the hospital to being admitted or to being in an admitted state is that the patient checks in. And so I'm going to double click on the transition line. I'm going to type in the event in the text box. Now, there's two things that can occur from after a patient checks in. One thing is that if they are diagnosed as healthy, there's nothing wrong with you, it was just a headache, or there's nothing wrong with you, then the event is, the next change in state is going to be the patient is released. And the event that is going to occur or that triggers that change in state is if they are diagnosed as healthy. And so I will write that on the line between the two states. But let's say, for instance, that there is something wrong and the patient needs to be checked into the hospital or needs to be put under observation, which would be a change in state, would be if their diagnosis was unhealthy. And so if you'll notice, there can be two separate outcomes or two separate state changes from being admitted to the hospital. At some point, they are no longer under observation and they will be released. So their state is going to change at some point from under observation to being released, and that is going to occur when the event is diagnosis equals healthy. So when the patient is deemed as healthy, they are going to be released. And then the last and final state from going from released to the final state is the patient is no longer going to be considered a patient, let's say, for instance, if 2 weeks have passed and they have not returned to the hospital. And so I'm going to put an event on this final transition from being released to the final state as healthy for more than 2 weeks, or more than 2 weeks passes before they return. Because I have not been to the hospital in a very long time, but I am pretty sure that in their books I am no longer considered a patient. Of course, my records are still in there as a former patient, but I am no longer a patient because it has been a very, very long time since I've been to the hospital. So, this is an example of a behavioral state machine. There is an initial state. There are a series of states that an object will pass through during its lifetime. And then there is a final state after which this particular object is no longer being used within the system. There are transitions, which are the lines between the states, and then there are the events that occur. The events that occur that cause an object to change from one state to the next. So the last thing that I'm going to do is I'm going to come back to these three events: diagnosis equals healthy, diagnosis equals unhealthy, and this one, and I'm going to make those guard conditions, because once again, it's from a programmer's standpoint or point of view, I'm asking myself the if statement that says, if the diagnosis is unhealthy, the patient is under observation. I will put the square brackets around healthy, because if the diagnosis is healthy, a patient will be released. And then this final one is also a guard condition, an if statement, which says if the diagnosis equals healthy, the patient will be released. And then the last part of this would be to indicate the boundary of the entire system. I notice in Visio that they do not have a boundary or a frame, and so I can go into more shapes. Under software and database software, I'm going to go into a UML use case diagram, because use case diagrams do have boundaries. And so I'm going to grab a boundary. Then I am going to go back into my Home tab, make sure that my pointer tool is selected, and I am going to drag this out, and I'm going to give it a name to indicate that this particular object that I am diagramming its change of state is called patient. All right, let's create one more behavioral state machine as an example. So I'm going to create a new one. I'm going to select on my state machine so I get all my state machine shapes. And this time we are going to create a simple state machine for another object that I know of that has a tendency to change its state over time. And this, say for instance, would be an air conditioning unit, an HVAC, which has a furnace and an AC that are connected to one another. So the states that this HVAC unit can take, there are actually 3 different states that we are going to list. Your HVAC unit can be idle. That means it's not running. It can be cooling at any given point in time, and it can also be heating at any given point in time. So I am going to click on this to indicate the fact that my HVAC unit is idle. This title is going to be cooling, and then this state, is going to be heating. Instead of adding a regular state for our heating, I'm actually going to add what is called a composite state. Because within a heating state, and I'm going to add the title of this one as heating, some of you have noticed that when your furnace comes on, it actually occurs or comes on in 2 stages. And so the 2 stages that a furnace comes on is it is in the process of activating, where it is thinking about coming on, and then another one of the states that it comes into would be called active. So it takes a few minutes, or a few seconds, I should say, from the time that my furnace knows that it needs to come on. It's thinking about it, it's plotting it out, it's planning it, and then it'll start blowing heat. And so we're actually going to use a composite state for this heating in order to indicate the 2 sub-states that this particular object will go through as a part of this one single heating state. All right, so the first part of building a simple state machine is to decide upon the context. And the context, or the use case, the object that we're going to be modeling would be my HVAC unit. The next step in building a behavioral state machine is to identify the states, and here I have identified idle, cooling, heating, which has some substates known as activating, and when it finally comes on and it is active. Then the next thing that I need to do is determine the sequence of events and then add the transitions. And the transition allow me to think of the triggers. What are the actions that execute that cause my object to move from one state to another? And so let me go back to my Home tab, make sure that I have on my connector tool, and I am going to draw a line or a transition from idle to cooling. And so my furnace is going to go from idle to cooling under what condition? What is going to cause my HVAC unit to turn on and begin cooling my house? And I'm going to put the trigger or the event that occurs, and that would be if it is too cold, and the method is going to pass the desired temperature. And so if it is too cold for the desired temperature, and I'm going to move in so that we can see this. If it is too cold for the desired temperature, my cooling is going to kick on. Then there's going to be another change in state from idle to heating. And of course, oh, excuse me, not too cold. I got that backwards. This is too hot. If it is too hot, then my air conditioning is going to kick on. I'm going to come over here and I'm going to say, now, if it is too cold, and the parameter I'm going to pass is the desired temperature. If it is too cold for my desired temperature, then my heating unit is going to kick on. Now, what would cause it to go directly from cooling to heating? Well, I'd ask Stephen, is it possible for it to go directly from cooling to heating? And I would say if it can do that, the reason why it would go from cooling to heating is once again because it is too cold for the desired temperature. And if you'll notice, the arrow is pointing in the direction of the change in state. I'm also going to say that if it can go from heating to cooling, is it possible for it to go from heat to cold? And I would say if it was too hot for the desired temperature, then perhaps it can go directly from heating to cooling. Now, what about from cooling back to idle? Because we have idle to cooling. Can we go from cooling back to idle? Absolutely. And so I'm going to draw a line. Let's see if we can get a line. And this one is going to be if it is at temperature, or if it is finally the desired temperature, then we are going to go from cooling back to idle. And then from heat back to idle, where it turns off once again, I am going to say that trigger or that event, or when it's finally at temperature, it is going to go from heating back to idle. And so if you'll notice, I have change of states from all 6 of these, or 6 different change of states depending upon the event that is occurring. Now, the last thing that I need to do is to talk about these composite or nested states. So when it comes to heating, when the heating is turned on either from idle or from cooling, there is a beginning state. As a matter of fact, we have not included our initial state as a part of this diagram. So I'm going to drop an initial state. I'm going to make him a little bit smaller so he fits in a little bit more with my diagram. Then I'm going to draw a connection from the initial state to idle. And then I'm also going to draw a final state, because we always drill to, or we always flow to, a single final state. And the final state is also going to go from idle to the final state. And the event that would occur that would cause it to go from idle to its final state, the event would be to shut down. And that will cause, let's say, for instance, if the final state of my furnace is I shut it off because I'm ready to turn on my swamp cooler for the summer or something like that. So if it is actually shut down to turn off for some reason, that would be the trigger that would cause my furnace to go from idle to its final state of being turned off. So if let's talk about the composite for just a moment. We need an initial state within the composite, and that is where I enter into this heating state. It is going to go from its initial state where I first enter it, and the very first thing that is occur, it is going to be activating. And then it's going to go from activating to active, and the trigger from the trigger that is going to cause it to go from its initial state when I first decide that I want to turn on the heater, or it is too cold and I need it to heat. Oh, let me come back down here. This is going to be when the unit is ready. And it's going to turn on. So the trigger that is going to cause it to go from activating to active is when it is decided that the unit is ready and it wants to turn on. So I can make this particular composite diagram just a little bit larger so that I can see that trigger a little bit better. There we go. Pull them apart just a little bit more so I can tell that I can read the event that is causing it to change state from activating to active. So I'm not going to add a final state within this composite state. I'm not going to add a final state because it goes from active to either too cold, or it goes to idle, or it goes to cooling. So I'm not going to add a final state inside of this nested state. Instead, I'm going to have an initial state where it enters, because I need to indicate the sequence of the flow. If I don't have an initial state, do I come in as active and then move to activating? So I have an initial state that is activating, and once the event that is going to cause it to move is called active. Once it is active, then the next step that will occur is either idle or cooling. This is an example of a behavior, another example of a behavioral state machine for an object known as an HVAC unit that is going to change its state. As I mentioned before, when I am trying to decide which objects I want to build behavioral state machines for, I'm not going to choose ones that don't change their state over their lifetime. If they're remaining steady, there is no point in modeling their change in state. So I'm going to select some complex objects. I'm going to create a behavioral state machine in order for me to be able to model or visualize or understand, get a better understanding of the states that this particular object can move through and the events that cause those state changes to occur. All right, so the last thing that I'm going to add to this is I'm going to add the boundary. I'm going to go back into my UML use case, and I'm going to drag a subsystem on here. I'm going to drag it out so that it is the correct size to indicate the boundary of my system. I'm going to give it a name, HVAC unit. I will add a condition on this initial state right here, and this initial state is where we turn the unit on. Let's say we had it installed and we have now turned it on, and it looks like my composite system is behind, and so I would want to make sure that that composite state, that I bring it forward over top of my subsystem. So I'm going to move this frame till I can see my composite state. Then I'm going to right click on him. I'm going to select the icon that brings him to the front. And then I'm going to move my frame back so I can see the entire thing. All right, so this is an example of the behavioral state machine, and that is all the tools that we're going to be learning about for Chapter 6. Have a nice evening.